So, here's what I'd like to provide us with. We just played the game 7, 13, 20 times. 20 times. Looking at it probabilistically, if we switched, there's a 4/7 chance that we win and a 3/7 chance that we lose. All I'm doing is I'm saying 7 times we switched. Out of those times we played, 7 of them we switched. So there's a 3-in-7 chance we lost and a 4-in-7 chance that we won if we switched. So switching yields a tiny bit of an advantage with our limited data set in that case. Staying is more even, but there's still a little bit of an advantage to staying. It's, 7-in-13 versus 6-in-13. But those are so close that it's almost 1-to-1. It's almost a 50-50, flip a coin, decide. What I'd like to do now is, this is less fun because it's not as graphic, but I made an Excel spreadsheet because I'm a dork that actually plays the game for us as many times as we want. So what it does, let me explain to you what's going on first. First of all, this keeps track of what trial we're on. So right now it's played the first game. It's first game. This random command right there chooses the door the prize is behind. So that's doing the same thing my TI was doing for me. I would push that button, look, and then put the lollipop where that prize is. That's doing the same thing. This right here, this random command, has you randomly choose a door. So it's saying I chose door number 1 and the prize was actually behind door number 1. That's why there's a 1 in the state and 1 box. Does that make sense? I hope that's fair. Monty shows you. This was one of the most fun commands I've ever had to write in Excel. Look at how long this thing is. Because of what Kyle said about 20 minutes ago. Depending on what door you pick. So when you guys picked a door that didn't have a prize behind it, it was easy. I just picked the other door that doesn't have a prize behind it. But when you pick the door that does have the prize behind it, I've got to choose randomly between the other 2. That's where that guy comes in. That's where that guy comes in. Totally.
So the prompt was, if correct, show...
Yes, if this equals this, then you can see it right there. If it doesn't equal that, then do this. Otherwise, do that. Yeah, totally freaking random. So anyway, the switch here, whether or not you decide to switch, is based off a random number. I did a 1 to 2. Okay, if you pick a 1, switch. If it's a 2, no. And then the result is, if they match, you win. If they don't match, you lose. So what I'm going to do now is I'm going to press F9, and F9 we play again. What just happened right now? We switched and lost. What just happened right now? We stayed and lost. What happened right now? We switched and won. So right there, that's proof that it doesn't matter what you do either. Let me grab my stapler. And I'm going to use the stapler to hold the F9 button down so you can see the game being played over and over and over again. And you keep track. What's going on right now is we've now played a game with 200 students. And we've kept track of what happened in every single case.
It's interesting how
That's weird.
That's weird. That's weird, because nobody called, I didn't hear anybody calling 66% before. I heard a lot of 50%. Right? I did hear Andrew mention 1/3 or 33% before. Andrew, is that coincidental with what's up here? No. Why are these?
It relates, but it's not exactly the same.
It is exactly
the same. It's not what I said.
It's not what you said, but what you said is actually exactly indicated by what's going on with the data. Now, we've played this almost 2,000 times right now. Do you believe these percentages are going to stay roughly what they are?
Yeah.
I mean, assuming that it's going to keep behaving the way it does, which there's no reason to think it won't, it's going to stay. This one's fluctuating a little bit down here, you might notice that. But they're not fluctuating like to 50-50 or to 70-30. They're fluctuating within 1 or 2 percentage points. Who could explain this? What do we got?
Well, when you remove one door, most people think you have a 50-50 chance because there's 2 doors. But in reality, you actually have a 2/3 chance of it being the other door.
Why do you have that?
Because you had 3 options to begin with. When you remove one option, you have now 2 choices.
Okay, so here's the doors as they were, right? Let's play the game very slowly with one lollipop. Can I throw one over here? Throw one over here if you don't mind, whatever flavor you want. Just toss me one. Bang, bang, bang. Okay, here's the lollipop. I'm gonna put it behind door number 1. Okay, and I say, pick a door. And I'm assuming you guys were picking doors randomly. That's how I was trying to control where my hair was and what my feet were doing and the dancing. So you pick a door randomly. What is the chance you pick the right door? 1 in 3. That's not very good. That's below 50-50, yeah? So that means there's a 2 in 3 chance that you pick the wrong door. So let's go through all the options. If the lollipop is behind door number 1, you can either pick door number 1, 2, or 3. There's 1 in 3, yeah? If it's behind door number 2, you can either pick 1, 2, or 3. That's still 1 in 3, yeah? And if it's behind door number 3, you can pick 1, 2, or 3. So there's your 9 outcomes that Benji was talking about earlier. In the 9 outcomes, 3 of them resulted in you picking the correct door that the prize was behind. So if you stay with the door that you pick, your probability is still 1 in 3. Because the prize doesn't move. The prize didn't, I never touched the prize. Once I put it in there, I just walked away, made dumb faces, dance, play with my hair, made stupid jokes, but I didn't touch the prize, yeah? So therefore, there's a 1 in 3 chance that you win if you stick with the door that you started with. Now look up here, look up here. If you switch, the chance that you lose is 0.34. Well, that's 1/3, essentially. That 1/3 directly ties to the fact that you picked the correct door. That directly ties. The only way you're going to lose if you switch is if what happened originally.
Is it the 33% chance?
Is if you actually pick the correct door in the beginning. That's the only time you're going to lose if you switch. If you pick the correct door in the beginning and you switch, you're going to lose.
Because your stay is based on an old data set.
Good, exactly. We can even ignore, ignore that for just a second, Ben, just a second. I want to come back to that. But let's just talk about the switching right now. Let's understand why switching makes you win 2/3 and lose 1/3 of the time. The only way you're going to lose if you switch is if you pick the correct door in the beginning, and how often do you do that? 1/3 of the time. So if you switch, the only time you're going to lose, and it's exactly 0.33 now, is if you pick the correct door in the beginning. Boom. Fair enough?
Because when you take away the option, you increase it to 2 and 3.
Exactly. It's almost like that door melded in with the here's the choice you really have. You have your door or all the other doors. Essentially, right? When Monty removes a door, it's almost like that door and this door are just the same door. You're still just picking either the one you picked or the other one. So really, if you think about it, it's an unweighted coin. Instead of 50-50, it's 1/3, 2/3. Let's come back to that. To wrap this up, let's look at this now. If you stay, this was the only comment that I heard earlier. It was like, Crystal, you were like, we stay. Taught to stay. The only way you're going to win if you stay is if what happens? If you pick the correct door. So the chance that you win is only going to be 33% because you have to pick the correct door in order to stay and win. Which means you're better off switching. Look, switching, staying loses 2/3 of the time, switching wins 2/3 of the time. You play the Monty Hall question. You play this Monty Hall thing, you switch. 2/3 of the time you win. It doesn't mean you're always going to win. It means 2/3 of the time you're going to win. We'll come back to this on Monday. I want to follow this up. Make sure, let this kind of stew in your mind over the weekend. Ask your parents, ask your brothers, ask your sisters, ask your spouses, ask your partners, ask people on the street randomly. They love this crap. Ben, it's a friendly town. I told her this anyway.
They did this on Mythbusters.
They did?
Yeah.
Awesome.
And they did 3 separate trials. See, 3 separate trials. The one